Hi, Mrs. Stanley here. Let's talk about composition of functions. The objective is to perform operations on composite functions. Before we can perform those operations, we need to be able to know what is a composition of functions. So let's read what it says here. Another method to combine the functions is called a composition. Given f of x and g of x, the composition function f of g x is defined as. This might be notation that you're not used to. It almost looks like the word fog, but it's not. So this is f of g of x. More commonly, you may have seen it written like this. This is what it means. A lot of times we see it written like this because it's just a little bit more functional, but this is what we're talking about. So let's come down here, the domain of f of g of x. I don't want this video to get too long, and so I'm going to link to another video that only goes over the domain, but I think maybe also as we do some examples, it will become more clear. So basically what this says, the domain of the composite function f of g of x is the domain of g such that g of x is in the domain of f. So basically you have to take the domain of the first function, the g of x, and so that limits your domain. Then you look at the domain of f when g is plugged into it, and that gives you the final limits on your total domain. Again, I think it feels or sounds more complicated than it is. Let's look at some examples, and also if you want to pause here, you can go watch the other video that I've linked and come back, or you can just see what happens with some examples. And if you don't need that other video, then that'll be great, no problem. So let's look at example 1. We have two functions, f of x and g of x. Notice that f of x is just a linear function, x plus 7, and g of x is a quadratic, x squared minus 4. So we've got, given f of x and g of x, find each function and state its domain. So we're going to need to be able to do that. Let's pay close attention to the order of the functions. We have f of g of x. So that means I'm doing g of x first. What is the domain of x squared minus 4? Is there any limit on what value we can have for x? No, the domain of g of x is all real numbers. What is the domain of f of x? Is there any limit on what we can plug in there for x? This is just a linear function. So again, this could actually be all real numbers. So that's very helpful for us, because what does that mean? If they're both all real numbers, then the domain is still going to be all real numbers. So let's look at our function. We've got, what we're doing here is f of g of x. So that means we're going to take whatever g of x and plug it into f wherever we see an x, okay? So what that means is I have x plus 7 for f of x. Instead, I'm going to write it out the first time, x plus 7. So what's going to happen is I'm going to erase the x plus 7, and I'm going to put g of x in place of that x. And I said that wrong. I erased just the x, not the plus 7. And I replaced g in there. So now I have x squared minus 4 plus 7. Because this isn't any multiplication or distribution that needs to be done, I can go ahead and simplify this. X squared, I don't know how I got so many different colors here. I've got x squared minus 4 plus 7. So my x squared stays the same. What's negative 4 plus 7? It's just plus 3. This is our final answer. And then what we know is the domain is all real numbers. Okay, so our final answer is x squared plus 3, and the domain is all real numbers. Let's look at the next one, g of f of x. So this time I've got g, and I'll write it out again, x squared minus 4. Wherever I have my x, I've got to erase. Now, I should have written it a little closer. The square is still there, just the x is gone. So what is getting squared? The f function, x plus 7 squared minus 4. So we've got to multiply that out because we need this to be simplified. So x plus 7 squared, remember we do x times x is x squared, plus 7x is going to give us 14x, and 7 times 7 is 49, and then we still have this minus 4 over here. We can simplify this, x squared plus 14x plus 49 minus 4. The x squared and the 14x stay the same, but 49 minus 4 can be simplified to 45. And then we need to know what's our domain again. Did our domain change? No, we still have the same f and g, so the domain is still all real numbers. And this would be our final answer right here. Okay? Let's look at example 2. This one is going to be a little bit more complicated. We've got f of x just a regular linear function. Look at g of x. What kind of function is that? We've got an x in the numerator and an x in the denominator, right? So this is a rational function. Let's look at these. First of all, it's going to be dependent, the domain is going to be dependent on if we're doing f of g of x or g of f of x, because we're going to have to see how everything kind of shakes out in the end. So first we have f of g of x. Let me write this out. 3 minus x. And then what do we know is going to happen? Instead of x, we're going to change it to g of x. So I'm going to erase this, and it's going to be 3 minus, I'm going to put g of x in there, x over x plus 1, right? And then what's going to happen, and if you need to, think of this as distribution, because we've got that negative sign there, right? So I'm going to erase those two parentheses for now because I don't really need them. But let's look at what's going to happen. We need a common denominator because this is subtraction with a fraction, right? So we need x plus 1 on the bottom, which means on this side we need to multiply by x plus 1 over x plus 1. And what do we get on top? We get 3x plus 3, and on bottom we have x plus 1 minus x over x plus 1. I feel like this is a tiny space to be writing in, but we can put this together. 3x minus x is 2x plus 3 over x plus 1. What do we know about our domain? Well, we know that the domain of f is all real numbers, so that's helpful. But in this case, we've done a composite with g of x. What limits do we have on the domain of g of x? Remember, we cannot have the denominator equal to 0. So for g of x, x cannot equal -1, right? Because if it were -1, we would have 0 in the denominator. So in this case, because f is all real numbers, the only limit we have is that it cannot equal -1. So we're going to say that our final answer is 2x plus 3 over x plus 1, with the denominator x cannot equal -1. And these are our final answer. Okay? I should have noted one thing when I was saying that. It's easy to see over here, x cannot equal -1 in the original function, but the reason we can look at that same limit is because right here it cannot equal -1, because that's still our answer, right? We have x plus 1 in the denominator, so the domain is still the same. Nothing changed in our new function. Okay, let's look at B. We've got g of f of x. So this time I'm starting with g, x over, let me write this smaller actually, x over x plus 1. Now that's going to change because everywhere that we have x, we're going to change it to f of x, right? So instead of x, this is going to become 3 minus x. And this x will also become 3 minus x. And now we can simplify this. On top, we still have 3 minus x. What do we have on bottom? 3 minus x plus 1. So that's going to be 4 minus x. Now we need to think about what is our domain now. Remember, originally f is all real numbers, so we don't have any limits from f. But for g, we're limited to what will make the denominator 0. In this case, -1 wouldn't make it 0 anymore because we got rid of just x plus 1, but instead we have 4 minus x. So x cannot equal 4, because if x was 4, we would have 4 minus 4, which would make the denominator 0. So our denominator is that x cannot equal 4. Our denominator, I meant the domain, is that x cannot equal 4 because it makes our denominator 0. So here's our final answer. 3 minus x over 4 minus x is the function, and the domain is that x cannot equal 4. Okay, hopefully you're getting the hang of this. At this point on example 3, go ahead and pause, try doing it on your own, okay? And then come back to the video and look. Okay, hopefully you've paused. If you just weren't sure where to get started, go ahead and get started with me and then pause and try to finish up. We see f of g of x, and if it helps you to rewrite it like this to know which function comes on the inside or the outside, that's fine. So for f, I've got this 9 minus 2x cubed. So I have 9 minus 2x cubed But what's happening? I'm plugging in g of x. So this one's going to be kind of a big substitution. I'm going to have 4x plus 1 cubed, right? So again, this one might be a little bit difficult for the writing in this tiny box, but go ahead and give it a try. If you had to look first, pause here to give it a try. Okay, here's the next step. We've done 4x plus 1 cubed. That's all we've done. And now we need to distribute our negative 2. Okay, so there we've distributed the 2. Now we can just combine like terms. We do have this 9 at the beginning and a negative 2 at the end, and so that can be 9 minus 2 is 7. And so we can put our answer in standard form. Here's our final answer. Our final answer, we've got negative 128x cubed minus 96x squared minus 24x plus 7. So that's our answer. And what do we know about polynomial functions and their domain? The domain is all real numbers. So in this one, we still have all real numbers. And then we can come to g of f of x. If you didn't try A on your own, definitely try B on your own, because you want to build up your confidence to know that you can do this without having to have a guide. So here's the first step. I've written out G, and I've exchanged, instead of x, I have the f function, 9 minus 2x cubed. So I have 4 times 9 minus 2x cubed plus 1. And I can just go ahead and do the algebra. I can distribute the 4. So there we've just distributed the 4. Now the last thing is to combine like terms. I've got negative 8x cubed. That's not going to get combined with anything. But the 36 plus 1 is going to become 37, because those are both constant terms. So I've got negative 8x cubed plus 37. Is there anything that can't be used in the domain? Again, this is a polynomial, so it is, it does have the domain of all real numbers. You can plug in anything for x. And so here is our answer for example 3. So I think that you can go ahead and try example 4 and 5 on your own. You do have an answer key to check your work if you need to. I do encourage you to do that. But let's jump down to example 6 and see there's a little bit of difference. Notice here the difference is we have f of g of 3, g of f of negative 5. So we no longer just have an x. Let's look at what that means. You may have seen this written before, where it would be like f of g of 3. Basically, where we were writing an x before, we've now got that value of 3. Let me fix this. I didn't like that 3. It wasn't very easy to read. So I've got f of g of 3. So the first thing I need to do is I need to evaluate g of 3. X plus 1, I just put 3. So 3 plus 1 is 4. That's easy enough. So then I use the answer for g of 3 to evaluate f. So I'm going to do f of 4, because g of 3 is 4. That's why it's f of 4. So it's the absolute value of negative 2 times 4, which would be the absolute value of negative 8, which would be 8. And then notice this time it doesn't ask us to give the domain. So once we found the answer is 8, that's all we needed. So let's try B. If you want, go ahead and try this one on your own and then check your answer. We're doing the same thing again, but instead of f of g, it's g of f. So I have g of f of negative 5. So the first thing I need to do is f of negative 5. What is f? The absolute value of negative 2 times negative 5. Well, that's going to be the absolute value of 10, which equals 10. So now I'm going to do g of 10. Because remember, I found the answer for the interior function, the one that was plugged in first, and then I'm going to use that to do the second part. So this one is just going to be x plus 1, which is 10 plus 1, which is 11. So our final answer is 11. Okay, now there's another one here on example 7, maybe a little bit harder functions, but we can still do this. F of g of 9. So this is f of g of 9. So the first thing we need to do is say, okay, what is g of 9? G of 9 is, what's the square root of x minus 4? 9 minus 4. So in this case, it's going to be square root of 5. So that's not necessarily fun, but let's keep going and see what happens. Now we have to do f of the square root of 5. So let's plug it in. X squared. So the square root of 5 squared plus 5 times the square root of 5. So what is the square root of 5 squared? It's just 5 plus 5 times the square root of 5. We can't simplify that because square root of 5 is, we could make a decimal, but we don't want decimals. We want the most precise answer. So our answer is actually done. Keep in mind that you cannot add these 5s. This would be like 5 plus 5x. 5 plus 5 times square root of 5 cannot be added together because we don't have a simpler answer for 5 square root of 5 right now. So like I said, treat this the same as you would 5 plus 5x or any other variable. B, let's try B. If you want, pause and do it on your own. I strongly encourage you to do that. I have g of f of 7. So I'm going to do f of 7 first. For f of 7, I've got x squared plus 5x. So I have 7 squared plus 5 times 7. So 49 plus 35, right? 49 plus 35 equals what? 9 and 5 is 14. Carry the 1. 4 and 3 is 7. So we got 84, right? And so now I'm going to do g of 84, which means it's going to be the square root of 84 minus 4, which is square root of 80. And we need to know, can this simplify? Well, what can be divided into 80? We know that it ends with 0, so 5 could go in there. 5 goes into 8 once with 3 left over. 5 goes into 36 times. So great, that worked out perfectly because we have 16 times 5. What is the square root of 16? 4. Square root 5 would be our final answer. Now we've got one more section here, and I do believe personally that this might be the hardest one. Let's look at this. They're telling you to find two functions, f and g, such that f of g of x equals h of x. So they're giving us h of x. Notice here on number 8, they're giving us h of x, and we're trying to figure out what two functions were combined here. I can tell you this is very important in calculus, so it's good that we're getting some practice with it. Now, the first thing to notice is where is my variable? And right now, I can see this 1 minus 2x inside the parentheses, right? So I might say that the g of x, the one inside, that was supposed to be my pen, not a highlighter, the g of x is 1 minus 2x. Because it says f of g of x, that means g is what's plugged inside. Think about it, if I had f of x as x cubed, and g of x is 1 minus 2x, then h would be f of g of x. We would have replaced the x with 1 minus 2x. Okay, let's try again on number 9. This is going to be one of those things that it's really going to be most beneficial if you just try to first look at it yourself and see what can you pull out. Think about what would possibly be a parent function that you see here. So for example, on number 9, I can see this cube root. So what if I had a cube root of just x? Then what would be my other piece? The x would have been replaced with x squared plus 1. So now we just need to decide which one is g and which one is h. Let me scoot these over because I didn't really give myself room to write the f and g of x. So let's look at it. The cube root of x would be the outside function. That would be f of x. And the g of x, x squared plus 1, would be the one that was plugged in. The x, let me change colors. This x was replaced with this x squared plus 1. That's how we know which one would have come first. Does that make sense? So I've kind of written them in opposite order, and that's okay as long as you label them correctly. Let's look at number 10. Again, we're trying to find what would be our g of x and what would be our f of x. So I'll let you think about it. Go ahead and pause, give it a try, see what you could figure out. Okay, so I'm going to first notice that x plus 7 is there on the bottom. And what if I just changed that to x? 4 over x minus 1. You see how that could happen? I could trade that x for x plus 7. So that's all I did was look at what could I trade. Look at the next one, number 11. I've got my g of x and my f of x. F of x is going to be the outside function. So it's this whole big thing. What if I had 1/2 the absolute value of x plus 3? That could be the original function, and then this g of x would be x plus 5. Because imagine if this wasn't here and this was just an x. And then we traded it for x plus 5, okay? That's what happened. So there's our two functions. All right, so go ahead and do the practice problems, and hopefully this was enough examples to help you understand these concepts.